Hi everybody, in this video let's look at chapter 6 from 5 modern math, chapter 6, ratio and graph of trigonometric functions. In this video I will just focus on 6.1, the value of sine, cosine and tangent for angle theta 0 degree under 360 degree. So I hope that you still remember this Dwakaso. Okay, what does this mean? It means that tangent is equal to opposite side divided by adjacent side. Cosine theta is equal to adjacent side divided by hypotenuse side. And sine theta is equal to opposite side divided by hypotenuse side. This you learn in Form 3. Still remember? In Form 3, the angle involved is just from 0 degree until 90 degree. So in this chapter, we are going to go further. The angle involved will from 0 degree until 360 degree. So just now I told you that tangent theta is equal to opposite side divided by adjacent side. Cosine theta is equal to adjacent side divided by hypotenuse and so on. But some students not very sure how to determine which one is the adjacent side, which one is the opposite side. Okay. Let me draw a right angle triangle for you first. Okay, let me do a quick revision about Pythagorean theorem first. So if you have a right angle triangle, so we have two shorter leg, two shorter side and one longer side, which we call it hypotenuse. This is hypotenuse, which is h. Okay, so if you want to find the length for the longer side, we use plus. C is equal to square root of a squared plus b squared. If you want to find the length for the shorter side, we use minus. For example, a shorter side, right, is equal to square root of c squared minus b squared. Minus. If you want to find the side length for b, shorter side, right, minus. b is equal to square root of c squared minus a squared. This one you learn in Form 3. I hope that you still remember. Okay, now let's go to how to determine the opposite side, adjacent side, and hypotenuse. Now we have a right angle triangle here. To determine the hypotenuse side, it is very easy because hypotenuse side is always opposite the right angle. But the opposite side and adjacent side, it depends on the position of theta. Now, if the angle is over here, let's say the theta is over here. This side, okay, let me label it first. A, B, C. BC is opposite the theta, right? So we call this side BC as opposite side. And AB is a side which is nearer to theta. So we call AB as adjacent side. Now, let me draw another right angle triangle for you. This time I will change the position of the theta. Okay, now I have another right angle triangle. This time, let me draw the theta over here. The hypotenuse side is still the same, which is always opposite the right angle. Hypotenuse. But now, the theta is over here. Let me label the vertex first. The theta is over here. So AB is opposite theta, right? So AB will become opposite side. And BC is the side which is nearer to theta. So BC is adjacent side. So just be more careful. Adjacent side and opposite side will depend on the position of the theta. If the theta is over here, this will be opposite side, and this will be adjacent side. If the theta is over here, this will be opposite side, and this will be adjacent side. Hypotenuse, no problem. It is always opposite the right angle. Okay, now let's learn about unit circle. A Cartesian plane can be divided into 4 quadrants. So we start counting the quadrant from here. This is the first quadrant, second quadrant, third quadrant, and this will be the fourth quadrant. Okay, now let's look at the first quadrant first. The angle is actually start counting from this side, or we can call this side as initial side. Initial side. And this side, where the angle stops, we can call it as terminal side. So if the angle goes this way, it will be a positive angle. So if the angle goes this way, it will be a negative angle. Let's say this is positive 48.3 degree. So if go down from here, go down 48.3 degree, this angle is negative 48.3 degree. But in modern math, we only focus on positive angle, which start counting from here and go anti-clockwise. You will notice that the radius of this circle is 1 unit, right? 1 unit. So we call this circle as unit circle. Okay, now let's look at this one. Now I have an angle of 45 degree. If I ask you to find the sine 45 degree, cosine 45 degree, or tangent 45 degree, okay, how do we get the answer? Definitely we can just use our calculator to help us, right? But first we need to understand this. Let me draw a right angle triangle for you first. Since this is a unit circle, the radius will always be one unit. This is the hypotenuse of this right angle triangle, right? So let's say the coordinate of this point is x, y, right? This means that this is y unit and this is x unit, right? Okay, go back to this dua castle. Let's learn about sine first. Sine theta is equal to opposite side divided by hypotenuse side, right? Now, this is 45 degrees, so this is theta. Opposite side will be y. Hypotenuse will be 1. So from here, we can make a conclusion that if you have a unit circle, right? If you have a unit circle, sine theta is equal to y coordinate. Cosine theta will be equal to adjacent side divided by hypotenuse. So adjacent side is over here, which is x unit. Hypotenuse is 1. So from here, we can make a conclusion that cosine theta is equal to x coordinate. Okay, now let's learn the last one, which is tangent theta. Let me write over here. Tangent theta is equal to opposite side divided by adjacent side. Opposite side, theta is over here. This is opposite side. This is adjacent side, DOA. So from here, we can make a conclusion that tangent theta is equal to y coordinate divided by x coordinate. Okay, so remember, if you have a unit circle, you want to determine sine theta, we take the y coordinate. Cosine theta, x coordinate. Tangent theta, y coordinate divided by x coordinate. And why we can proceed one more to get one more information. Tangent theta is equal to y coordinate divided by x coordinate. Y coordinate is sine theta. X coordinate is cosine theta. Okay, so this is another information we can get from here. Remember, sine theta is equal to y coordinate, cosine theta is equal to x coordinate, tangent theta is equal to y coordinate divided by x coordinate, and tangent theta is also equal to sine theta divided by cosine theta. Okay, so maybe you are now feeling a little bit confusing. Sine theta is equal to y coordinate, cosine theta is equal to x coordinate. What does this mean? Okay, let me show you this one. Now, you look at my coordinate over here. Now look at this point. The coordinate, now you have a unit circle. The coordinate of this point is 0.7042 and 0.71. I just round off it to, I just set the accuracy to 4 decimal places. Now, according to what I told just now, sine theta is equal to y coordinate, right? This means that sine 45.2358 degree is equal to this. Okay, let's use our calculator to check. Sine 45.2358 degree. 0.7100 and something. Okay, here is all round off to 4 decimal places. Now, how about cosine theta? Cosine theta is equal to x coordinate. So we should be able to get 0.7042. Let's use our calculator to check. Cosine, oh, let me delete this one. Cosine 45.2358 degree. We should be able to get this. 0.7042. Okay, so how about tangent theta? Tangent theta is equal to y coordinate divided by x coordinate, right? Okay, so first let me use this divided by this first. 0.71 divided by 0.7042. We get 1.008. Okay, so remember this number, 1.008. How about if I just directly press tangent 45.2358, 45.2358, we still get the same thing. Okay, hopefully now you understand better about this one. Sine, if you have a unit circle, sine theta is equal to y coordinate. Cosine theta is equal to x coordinate. Tangent theta is equal to y coordinate over x coordinate. And tangent theta is also equal to sine theta over cosine theta. Okay. Since that sine theta is equal to y coordinate, cosine theta is equal to x coordinate, and tangent theta is equal to y coordinate divided by x coordinate, any angle which is in this first quadrant, this is first quadrant, second quadrant, third quadrant, and fourth quadrant. Any angle which in the first quadrant, sine, cosine, tangent, all will be positive. Why? Because in this quadrant, the y coordinate, x coordinate, all will be positive, right? Therefore, all will be positive. Sine, cosine, and tangent, all will be positive. Now, how about when I proceed it, go to second quadrant. This is second quadrant. Y coordinate still positive. This means that sine will still positive. Since sine theta is equal to y coordinate, right? So the y coordinate is still positive. So in this quadrant, sine will still positive. Cosine theta is equal to x coordinate. Now the x coordinate is negative, so cosine will be negative. Just let me quickly show you this. Cosine 134, 1. Okay, I just press 134. We get negative value. If you press sine, you'll get a positive value. And tangent is equal to y coordinate divided by x coordinate. You take this divided by this, positive divided by negative, you will get negative, right? Okay, so here, let me write this one. Sine, you will get positive. Cosine, you get negative. And tangent, you will get negative too. How about if we proceed to the third quadrant? This is third quadrant. You will notice that now the x coordinate and y coordinate will be is already negative, right? So sine will be negative. Cosine will be negative too. How about tangent? Tangent is equal to y coordinate divided by x coordinate, right? So negative divided by negative, you will get positive. So in this quadrant, tangent will be positive, the rest will be negative. In the second quadrant, only sine will be positive, the rest will be negative. Now let's proceed to the last quadrant. Quadrant number 4. Okay, so sine theta will be y coordinate. You will notice that the y coordinate is negative, right? So sine, negative. How about cosine? Cosine is x coordinate. The x coordinate is positive. How about tangent? Tangent is y coordinate divided by x coordinate, which means this divided by this. Negative divided by positive, you get negative. Okay, now remember this. In the first quadrant, all will give you positive. Second quadrant, only sine will be positive. Third quadrant, tangent will be positive. And the fourth quadrant, cosine will be positive. So there are many ways to remember this. Some students just like to memorize this way, ASTC. Or you can just remember like add sugar to coffee and so on. You can use your own way as long as you can remember this, ASTC. First quadrant, all positive. Second quadrant, sine positive. Third quadrant, tangent positive. And the last quadrant, cosine positive, ASTC. Okay, now let's learn how to find the reference angle. Always remember, the reference angle is always the angle between the terminal side, which means where the angle stops, and the x-axis. If the angle is over here, no problem, the reference angle is just 47 degrees. If the angles come under here, where is the reference angle? The reference angle is over here. Always remember, the corresponding reference angle is the angle between the terminal side and the x-axis. Remember this, x-axis. So how do we get this angle? We just take 180 degrees minus 144 degrees, right? Which you will get 36 degrees. That's 36 degrees. Okay, now how about if the angle go under here? Where is the reference angle? Always remember, the reference angle is always the angle between the terminal side where the angle stops and the x-axis, not here. This is not the reference angle. It should be here. Okay, try to think, how do we get the size of this angle? From here to here, all the way to here is 220. So what is the angle here? You know, right? We take 220 minus 180, minus 120, because here minus 180. Here is 180 degree, right? So from here to here is 220 degree. If we want this angle only, okay, let's be alpha. So the alpha will be equal to 220 degree minus 180 degree, which is 40 degree. Okay, let's move on to the last quadrant. If the quadrant, if the angle come to the last quadrant, where is the reference angle? Always remember, reference angle is always the angle between the terminal side where the angle stop and the x-axis. The reference angle is over here. Okay, how do we get the size of this angle? A full turn will be 360 degree, right? So here is already 333 degree. To get this side alpha, the size of this angle, it will be 360 degree minus 333 degree, which is 27 degree. Okay, so remember, to determine the reference angle, always look for the angle between the terminal side, where the angle stop, and x-axis. Okay, until now, what have we learned? We learned about ASTC. In this quadrant, all positive. In this quadrant, only sine positive. In this quadrant, tangent positive. And in the last quadrant, only cosine positive. And also, we learned about how to get the corresponding reference angle, right? Okay, now we are going to apply these two knowledge to help you to solve this question. These questions are taken from a textbook. I will discuss some questions with you, so the rest you need to try on yourself. Okay, now let's look at a sine 128 degree. Determine the value of each of the following based on the corresponding reference angle. So in this situation, we cannot just press, yes, you can just press your calculator to get the answer. For example, you can just press 128 degree. But in this question, the question asks you to get the value based on the corresponding reference angle. You have to learn how to determine the corresponding reference angle first. If you just press the calculator, just press your calculator and get the answer, you will have a hard time when you are going to learn the next part. So in this part, make sure you understand how to find the corresponding reference angle. Okay. So first, I will suggest you to sketch a diagram. 128 degree. So remember, start from here, right? Start from here. 128 degree will go to somewhere around here. You don't have to use a protractor and measure, we just roughly sketch it. The most important thing is we need to know where the angle is in the first quadrant, second quadrant, third quadrant, or fourth quadrant. Then only we know that the value is positive or negative. Now, this is 128 degree. What's the size of corresponding reference angle? Or we can call it reference angle. The reference angle is over here, right? Always remember, the reference angle is the angle between the x-axis and the terminal side. Okay, so how to get this angle? I think it should be no problem. Reference angle. Or you can call it corresponding reference angle because your textbook using corresponding reference angle. How do we get this angle? We take 180 degree, right? Minus this, so that we can get this angle. So this will be 52 degree. So this is 52 degree. Okay, so we have determined the reference angle. So the next step is to write this. Sine 128 degree is equal to sine 52 degree. And then we start to think, should I add a negative sign over here? According to what we learned just now, ASTC. In this quadrant, sine should be positive, right? Therefore, we don't have to add a negative sign here. Okay, now you just press your calculator, sine 52 degree. Sine 52, you should be able to get 0 0.7880. Okay, so this is the answer. If you want to double check whether answer correct or not, you can press sine 128. You get the same answer, right? Okay, now next question. Let's try B. We want to determine the value of sine 236 degree based on the corresponding reference angle. So first is to sketch the angle 236 degree. We know that from here, always remember start counting from here and go anti-clockwise. Since that the angle is positive, if the angle is negative, then we go from here, go clockwise. Okay, 236 degree somewhere around here. Okay, why is here not the fourth quadrant? Because this is 90 degree, right? 0 degree or 360 degree. And this is 180 degree, and here is 270 degree, right? So 236 degree is between 180 degree and 270 degree. So we know that the angle stop here. Okay, so this is 236 degree. The second thing is to determine the corresponding reference angle or reference angle. Okay, so the reference angle is always between the angle between the terminal side where the angle stop and the x-axis. Remember, x-axis. This angle that we need. So how to get this angle? Try to think. 236 degree from here to here. But now I only want this, right? So you take 236 degree minus 180 degree. Okay, so, oh sorry, it should be 56 degree. 56 degree. Okay, next thing. Sine 236 degree is equal to sine 56 degree. You write this first and then you start to think, should I add a negative sign? According to this ASTC, in this quadrant only tangent positive. Now we are talking about sine, right? So we need to add a negative sign. And the next step, copy the negative and press your calculator, sine 56 degree. Sine 56 degree. 0.8290. 0.8290. Okay, so same thing, if you want to test whether this answer correct or not, you can press sine 236 degree. You will get exactly the same answer. Okay, so next let's try part D. 196 degree, cosine 196 degree. Same thing, the first step is to sketch a angle or sketch the angle 196 somewhere around here. 196 degree. So the corresponding angle is angle between the x-axis and the terminal side. Okay, reference angle is equal to 196 degree minus 180 degree. Okay, so this is 60 degree. Next step, write this. Cosine 196 degree is equal to cosine 16 degree. And then we start to think, should I add a negative sign? According to this ASTC, in this quadrant, only tangent positive. Now we are talking about cosine. We need to add a negative sign. Okay, next step, just copy the negative sign and press your calculator, cosine 16 degree. Cosine 16 degree. Okay, 0.9613. 0.9613. So same thing, if you want to double check your answer, you can press cosine 196. You will get the same answer. Okay, now let's go to E, cosine 289 degree. First step is to sketch the diagram, sketch the angle. Cosine 289 degree will be somewhere around here. 289 degree. And where's the reference angle? The reference angle is between the terminal side and the x-axis, which is over here. And try to think, how do we get this angle? (360 degree minus 289 degree, right? This will give you 71 degree. Now, next step, cosine 289 degree is equal to cosine 71 degree. And then we start to think, should I add a negative sign? According to ASTC, we know that in this quadrant, cosine should be positive. Now, we are talking about cosine, so we don't have to add a negative sign. Just press your calculator, cosine 71. Cosine 71. 0.3256. Okay, so next questions, let's try K. Sine 341.7 degrees. Same thing, the first step is to sketch this angle. 341.7 degree will be somewhere around here, fourth quadrant. And the corresponding reference angle is between the terminal side and the x-axis. Remember, x-axis. This. In order to get this angle, we have to take 360 degree minus the angle here is 341.7 degree. Okay, then just press your calculator. 341.7. 18.3 degree. Okay, the next step, sine 341.7 degree is equal to sine 18.3 degree. And then we need to think, should I add a negative sign here? ASTC. In this quadrant, only cosine positive. Now we are talking about sine. We should add a negative sign. Next step, just copy the negative sign and press your calculator, sine 18.3. 0.3140. Okay, let's try one more. N. Okay, now the angle is given in degree and minutes. So still remember, 1 degree is equal to 60 minutes. First is to sketch this angle, 102 degree and 38 minutes. So it should be somewhere around here. The reference angle is between the terminal side and the x-axis, which is here. How to get this angle? (180 degree minus 102 degree 38 minutes. So this you can just press your calculator. 180 minus 102 degree 38 minutes. Okay, so you get this one. You can if you want to write your answer in degree and minutes, just press this. 77 degree 22 minutes. So this one you can press degree also, but if you don't want to press degree, it's okay. Your calculator know that it's a degree because it already set in degree. 77 degree 22 minutes. Okay, 77 degree 22 minutes. Let's say if you don't want to use your calculator, we can do it this way. Degree. This one you learned before. I hope that you still remember. So now this is 102 degree, 120 degree. 102 degree, and this is okay. We are taking 180 degree minus 102 degree, 38 minutes. Okay, so this 0, 0. So now here 0, 0 cannot minus 38, right? So we have to borrow from here 1 degree. It becomes 179 degree. 1 degree is equal to 60 minutes. So here will become 60. So 60 minus 38, you will get 22. 179 minus 102, you will get 77. Okay, so this is the way how we calculate manually without using our calculator. 727, 77 degree and 22 minutes. Okay, next step. Now we are talking about tangent. Tangent 102 degree 38 minutes is equal to tangent 77 degree 22 minutes. And next we need to think, should we add a negative sign over here? So we have to refer to ASTC. In this quadrant, sign positive, the rest will be negative. So we are talking about tangent now. So we need to we know that we need to add a negative sign. Copy the negative sign and press the calculator. Tangent 77 degree 22 minutes. Okay, the answer is negative 4.4615. 4.4615. Same thing, if you want to double check your answer, you can just key in this whole thing inside your calculator, see whether we get the same answer. 102 degree 38 minutes. Okay, same answer. So that means our answer correct. Okay, now let's try a few more questions. As you remember, even though I already showed you the calculation, the solution, when your school teacher asks you to do the homework, you cannot just copy my answer, because if you just copy without thinking, you actually learn nothing. You have to understand it and do it yourself. Okay, now let's look at this 6.1c. I will use question 1 as an example. Determine the value of sine, cosine, and tangent for each of the following angle without using a scientific calculator. Normally, without using a scientific calculator, the angle involved will be like 45 degree, 30 degree, 60 degree, and so on. So still remember, in Form 3, you already memorized these two triangles. I hope that you still remember these two triangles. Okay, so this one is an isosceles triangle, 45 degree, 45 degree. This is 1, 1 square root 2. And this is 60 degree, 30 degree, 1, 2 square root 3. Okay, these two triangles, you need to remember it. Now, let's try a few questions here. Let's try B. So we are going to find the sine, cosine, and tangent for this angle. The step is just like just now, but now what is different is we are going to use this triangle, what we memorized, instead of using a scientific calculator. Okay, 135 degree. First is to sketch this angle, 135 degree is from here all the way to here. 135 degree. Second, we need to determine the corresponding reference angle here, right? Okay, the reference angle is equal to 180 degree minus 135 degree. Okay, 45 degree. Now, sine sine 135 degree is equal to sine 45 degree. Write this first. And then we start to think, should we add a negative sign? A, S, T, C. So in this quadrant, sign should be positive, right? So we don't have to add a negative sign. Now we need to refer back to the triangle. Sine is SOH, opposite divided by hypotenuse, which is 1 over square root of 2. Okay, so this is sine 135 degree. Now let's go to cosine. Okay, cosine we can just write the short form COS. Okay, same thing, we write the cosine 135 degree is equal to cosine 45 degree first. And then we start to think, should we add a negative sign? In this quadrant, only sign positive. We are now talking about cosine, so we should add a negative sign. Okay, negative sign, you just copy it. For the cosine 45 degree, refer to this triangle. CAH. Tua, Ka, So. CAH. Okay. Now let's go to tangent. Tangent 135 degree is equal to tangent 45 degree. Write this one first, and then we start to think, should we add a negative sign? In this quadrant, only sign positive. Now we are talking about tangent, so yes, we should add a negative sign. Copy the negative sign, and for the tangent 45, refer to this diagram, DOA, opposite divided by adjacent, which is equal to 1. Okay, now let's try one more question. Given sine theta is equal to square root 3 over 2, calculate cosine theta, tangent theta without using a scientific calculator. So now, let me show you the first method first. Sketch a unit circle. Since this sine theta is positive, we know that the theta, this angle, must be in the first quadrant or second quadrant. Right? Because ASTC, first quadrant and second quadrant, the sign is positive. Now, we want to calculate cosine theta, tangent theta. Still remember just now what we learned? If you have a unit circle, sine theta is equal to y coordinate, right? So this is square root 3 over 2. And the x I don't know, I just write pp. If the angle is over here, the second quadrant, the y coordinate the same, square root 3 over 2, and this one, I don't know, I just write bq. Okay, next, let me draw a right angle triangle for you. In order to get the cosine theta and tangent theta, we need the side length for this part, right? This is already, we already know that this side, the side length here is square root 3 over 2. How about here? This is P, right? This is P. And since this is a unit circle, we know that here must be 1 unit. Okay, let me calculate the length over here first. Still remember what I told you just now? A right angle triangle, we have 2 short sides and 1 long side. If you want to find the side length for the shorter side, for example P, we use minus 1 square minus this square root, or square root the whole thing. So this will give you 1 square root 3 squared, you will get 3, 2 squared, you will get 4. Okay, so this square root 1 over 4, which is equal to 1 over 2. Now you know here is actually 1 over 2. This is 1 over 2. Okay, now can you get the cosine theta and tangent theta? Should be no problem, right? In the first quadrant, let's do the first quadrant first. Cosine theta is x coordinate. Cosine theta is equal to 1 over 2. Tangent theta is y coordinate divided by x coordinate. This one divided by this. Okay. Square root of 3 over 2 divide, we can change become multiply, then when we interchange the numerator and denominator. 2 go up, 1 go down. Simplify it, you will get square root 3. Okay, how about in the second quadrant? If this is 1 over 2, here must be negative 1 over 2. Because it goes this way, right? This is positive. Go this way, it will be negative. So cosine theta is equal to x coordinate, which is negative 1 over 2. Tangent theta is equal to y coordinate divided by x coordinate, which you will get square root 3 also. But this is negative, so you will get negative square root 3. Okay, now let me show you another method. Given by the question, sine theta is equal to square root 3 over 2. When you refer to these two triangles, you know that here we have square root 3 and here we have 2. We know that this theta can be taken from this triangle, right? As OH. So it should be sine 60 degree. Sine 60 degree is equal to square root 3 over 2. Now we know that this angle is actually 60 degree. And just now we learned about ASTC. It can be in the second quadrant also. So 60 degrees is over here, the reference angle. This angle will be 120 degree. Okay, now we can use the method like what we did just now to help us to get the answer. Okay, I will show for the quadrant 2. So this one you can try yourself. Okay, cosine. Since we know that the angle is 120 degree, cosine 120 degree. Or how about let me write this one first. Cosine theta is equal to cosine 120 degree. Okay, so the reference angle is 60 degree, right? Cosine 60 degree. And then we start to think, should we add a negative sign? Yes, because in this quadrant, only sign positive, right? ASTC. Now we are talking about cosine, we need to add a negative sign. And then refer back to this triangle. CAH. Copy the negative sign. Cosine 60 degree is equal to adjacent divided by hypotenuse, which is 1 over 2. We get the same answer. Okay, now let's go to tangent. Tangent theta is equal to tangent 120 degree. And the reference angle is 60 degree. Tangent 60 degree. And then we start to think, should we add a negative sign? ASTC. In this quadrant, only sign positive. Now we are talking about tangent. We need to add a negative sign. And then copy the negative sign. And tangent 60 degree, just get it from your triangle. TOA. Opposite divided by adjacent. Square root 3. Okay, so this is the way how we get this the answer for this question using another method. Okay, that's all for this video. hopefully understand better after watching this video. See you next time. Thanks for watching. Bye bye.